All right, welcome everybody. Going to give folks a few moments to join, and we'll do a quick intro before we get started with today's webinar. All right, looks like we've got a good amount of folks hopping in already. So thank you everyone who's joining us today for Take Advantage of Your Vertical Surfaces, Building Integrated Photovoltaics. It's going to be presented today by Terri with the Mitrex team. This has definitely been one of our most popular courses, so really excited to dig into the world of BIPVs. I know it's a very exciting topic, and I think we've got some really great info to share with you today. Before we get started with the CEU portion of today's event, I'm just going to give a quick introduction about Acelab. We're helping out with hosting today's webinar and give you guys some information on what to do after today's event if you're looking to get some more info. So I'll share my screen here and then we'll go ahead and get started. All right, so everyone who joins an Acelab webinar, you get an automatic free Acelab account. You can come back here to explore some of the resources and tools that we provide. I'll be dropping some helpful links in the chat throughout today's webinar. One of them will be a meeting link for my colleague if you're interested in a free quick demo to get all set up on our platform. What I want to show you today is really just what to do if after today's webinar you're looking for some more information. You can use the search bar at the top, type in the name of any product, any brand. It'll cross search between all of our resources. You can head over to a brand page on Acelab. Scrolling down here, you can use this button to get in touch with Terri directly, communicate with her through our platform. It's integrated with email as well. And then you can learn some more about Mitrex and Cloudify. Scrolling down here, you can save these products to your projects or to your general research folders if you're looking to just come back to them for future reference. And you can also access downloads such as product literature and CAD files by clicking on these as well. All right. I think other than that, I just want to mention after today's webinar, you'll have the option to let us know if you're interested in chatting more with Mitrex. And if so, we'll go ahead and connect you directly. To get to your conversations on Acelab, you can head to this top right corner and click on this conversations icon. You're also going to get an email about any new connection that's made, so you can respond directly to those as well. This can be a great place to come and just get an overview of all your communication, keep it organized along with your product research. All right, and then last thing I want to share is just a quick little preview of kind of the overall benefits of using Acelab. We're recently launching this great new schedules tool. If you're interested in getting set up with this, it's a really awesome way to store your product information along with your rep information. And our team is on standby to help you get this all set up. So I'll send over some links for free demos, as well as some links to the Mitrex and Cloudify pages on Acelab so that you can get to all of this super easily. Last thing I'll mention, just some housekeeping items from me. This is a CEU approved event. We did ask for AIA numbers upon registration. We'll also send over a form in the chat momentarily where you can give us your AIA number or request a certificate. And then lastly, just want to encourage folks to ask questions. You can use the Q&A to submit any questions. We'll keep our eye on those, should have some time to get to some live. If we don't get to your question live, we'll have a record of it. We can follow up after today's webinar. All right, that's it for me. Thank you everyone so much for joining today. And thank you, Terri, for being our presenter. Feel free to get started whenever you're ready.
No problem. Thank you everyone for joining. I do have to say one thing, Bo. The photo on your platform is at least 12 years old. I have white hair now, so you might want to update that.
Update your profile picture. All right, you send me a new one and we'll get that fixed.
They're going to see the photo and they're going to remember the person that was on live and they're like, nah, it's not the same person. Yeah, I've aged a little bit.
You do have dark hair in that photo.
That was my natural color. This is the natural color now. That's crazy. Okay. Thank you. All right. Thank you to everybody. Just give me 1 minute to share my screen and I'm going to bring up the presentation. So let me just confirm. Okay. Can you see the can you see the presentation full screen?
Yeah,
good?
I can.
Excellent. All right. As Bo mentioned, my name is Terri Oswald. I have been with Mitrex for 7 years now. I am a very proud representative of our technology. So today we're going to go over a little bit about our company history, the technology, a little bit about sustainability. So we're going to cover a lot of topics. As Bo mentioned, feel free to, list your questions and I'll leave plenty of time at the end of the presentation to address those. Okay. So, oh, there we go. Oop. There we go. So Mitrex is actually a division of GCAT Group. Our company has been around for 25 years. We understand the manufacturing and installation of our technology. Unlike a lot of other manufacturers, we actually install our own technology. So we get it. We have a very, very robust insight into the construction process. We are located in Toronto, proudly North American. And as I said, we've been operating for a very long time. We launched our Mitrex solar technology in 2020, just before COVID. Not the best time, but it's worked out very well, actually. So today we're going to cover the pardon me, CEU credits, which, as Bo mentioned, please supply your information, and that will be registered on your behalf. So today we're going to cover the basics of solar energy. We're going to talk a little bit about BIPVs and how they improve on traditional photovoltaics in terms of design and performance. We're going to talk about how you can integrate this technology into your projects. We're going to talk a bit about money and energy savings. So we're going to cover a lot, but I'm going to keep it as basic and as simple as possible. I don't want to completely overwhelm you. So sustainability in the building industry. It's a very interesting topic because sustainability is different things to different people. So for some, sustainability is using a different type of light bulb, right? So changing light bulbs or changing HVAC systems or looking at geothermal systems. So there's a lot, but the fact is that sustainability can be integrated to the vertical surfaces of a building. And that's what we're going to talk about today, is a high performance system that is not only an incredible building material, but it, transforms the building into an energy generating machine. So our roots are simple. We started 25 years ago in stone. Our CEO said, I feel like a modern day pharaoh and things need to change. So he found a way to cut stone super thin, get it on an aluminum honeycomb back, and created 3 millimeters of real stone without the weight, without the challenges of structural support, and all the challenges that come with logistics and installing that technology. And then fast forward 20 years to 5 years ago, we introduced solar technology. And so basically, instead of a thin stone or a thin porcelain or a thin brick, we replace that with glass, right? Very simple, glass. It starts off low iron, or it starts off clear, it's low iron, and we customize it. And we're going to get into the details of that. So that has been the genesis of our technology. How the technology is manufactured is like this, in a facility that is over 100,000 square feet. It is fully automated and robotic. Mitrex is the largest manufacturer in the world of this technology. We're very proud of the fact that we are North American born. All raw individual components come to our facility, and it is pre-assembled and manufactured all under one roof. So our legacy technology from 20 years ago and our current solar technology, both are manufactured all in one facility. Very exciting. So the mission of BIPV is actually really simple. So after years of research and development, we realized one thing: the sun does not know if you are a high rise, a low rise, a residential, an airport, a hospital. It makes no difference. The fact is that every surface that is touched by the sun should and could generate electricity, plain and simple. So we apply this to all of our projects. What we want to do is change the world one building at a time, and we are doing it. So the question becomes, why do you want to use BIPV technology? There are a lot of advantages. So the biggest is to generate a substantial amount of electricity. For example, this project in this photo here, the entire facade is going to be BIPV. We'll be on construction next year and installing this technology. And this building is going to generate 43% of the building's daily electrical needs. That's what BIPV technology will do. It will utilize vertical surfaces that typically are under or unutilized with this technology. So a solar facade will significantly reduce a building's carbon footprint. It will generate electricity. It will transform a building into a power generation station, period. And it can take your building from energy efficient to net zero. So the basics of solar are very simple. unlike a lot of misconceptions, solar technology has been around for a very long time. So what we've done is taken an existing solar technology and an existing panel that we've been manufacturing for years and brought the technology together. Solar cells themselves have been around for a very long time. So they were first discovered in the 19th century. Photons carry energy proportional to the wavelength of light. So the surface, once exposed to the sun, will absorb light energy, and with enough energy, the surface releases electrons, which create electricity. Okay, and materials that use this are called photovoltaics. Many of you are familiar with rooftop photovoltaics. It's the same concept. The only difference is instead of an angled application on a roof, it is a vertical application in the facade of a building. Okay, so sustainable energy generating facades at no extra cost. You substitute BIPV for the existing material you have in mind. So it's one or the other. It's not both. Unlike rooftop solar, that is an extra cost, an extra addition to a building. What you're doing is, if you've got metal panels in mind, or precast, or GFRC, or something else, you are replacing that material with a building integrated photovoltaic panel. So your cladding is your solar is your cladding, right? The construction of the panel is very simple. So you have your glass facing, which starts off clear. You have your encapsulant, which holds the solar cells. You have your solar backsheet. You have your junction box, and you have the aluminum honeycomb backing. So aluminum honeycomb is at the core of all of our cladding solutions. That is whether it is an active solar cladding panel or a non-active solar cladding panel. So we manufacture two very distinct categories of technology: our non-solar, which means no solar cells, and that is facings of stone or porcelain or brick, or we can apply aluminum PVDF coatings to come up with our own ACM panel. Or on the solar side, we replace that facing of stone or porcelain or brick with glass. It's clear, it's fully customizable, so we can do things to the surface of that glass to create a endless possibility of colors and patterns. So creating the cladding panel is fantastic, but if you can't get it on a building easily, what's the point? This is where our legacy product and our years of in the construction industry come into play. We have devised 3 installation methods that work for all types of buildings. So depending on the nature and the design of the building will dictate what type of system we use. So we have a rain screen application, we've got a unitized system, and we have a prefab wall system. In our Cloudy Shield system, it's very simple. It is a rain screen application that is fully adjustable. You can get insulation behind. It's continuous insulation and air water barrier. You can achieve irregular designs. You can have pre-panel, pre-assembled panels. It is a precise installation. There's a lot of different design elements we can achieve. It has less connection points, so you're dealing with reduced thermal bridging. So there are a lot of advantages to this type of technology. Our second installation is our cladditized system. This acts as a substitute for precast. It installs the same way. It's a slab-to-slab connection, but precast is 100, 150 pounds per square foot. Our technology is 5 pounds per square foot. So all of the logistical challenges that come with dealing with the heavy material, all the structural support that you typically need can be eliminated. The beauty is, as well, you do not require a tower crane. So, 2 people can, handle this material and install it from the inside of the building. So from a logistical standpoint, that is, saving a lot of time, reducing trades on site, et cetera, et cetera. It's the same thing with our Claddifab system. Same installation method. It is a slab-to-slab connection, but it is a full wall assembly. So you have your exterior, you have your insulation, your vapor barrier, your fire stop. So all of the components are integrated directly into the panel. And again, no tower crane required, installed from the inside, all the same advantages to our previous system. Customizable integrations and special projects is where we have built our reputation. There are a lot of things that you can do because of the lightweight panel. So you can achieve projections, recesses, you can do unusual shapes and designs with simple miter cuts or, some pre-assembly. Lots of things that we can do with that. So the components for a BIPV system are the exact same as a rooftop. You have your optimizer, you have your transformer, you've got your switch gear. It's all the same. As I said, the only difference is instead of an angled application on a rooftop, you're looking at a vertical application in a building's facade. The electrical wiring is the same. They are connected in series. You could have 15 panels connected to each other. It's a simple male-female connection. There is a bypass diode on the back of every single panel so that in the event that something happens to one panel, it will not affect the performance of any of the panels that are connected to it, right? It's kind of like Christmas tree lights. Today, anyway, when I was a kid, I was the sucker who had to figure out which one light bulb went out, and I had to dismantle the entire tree. If we were to do that today, we'd be out of business. So clearly that's not an issue. So if one panel goes down, it makes no difference to the performance of any of the panels connected to it. Inverters, how many do you need? Where are they installed? What do the conduits look like? All of that, all of those details are figured out on a project by project basis. We don't know anything in advance. Every project is unique, so we analyze it as they come in, and we make recommendations on size and location of inverters and wiring and all that kind of stuff as we go. There is a monitoring system that is attached to this technology, so your clients will always know how the building is performing. If they want to specifically know what the west elevation is doing, they can have that information. Once the system is up live and running, if they want to go back and say, what were we doing? Let's see, today's November 21st. What did the west elevation do 3 years ago today? All of that historical data is available. So you can either get online on your computer, or your client can pull out their phone and open up the app and see, how the building is performing. The services that we provide are as simple as, design analysis and review, right down to full installation and everything in between. So whether it is design assist, whether it is just, assisting with project design or project management, everything from A to Z is part of our full turnkey solution, or you can treat it as a la carte, if you will. So that's cladding we talked a lot about. There are a lot of different applications for this technology. Cladding is by far the largest area of opportunity. But aside from cladding, there are other areas where you can apply this technology. And solar railing is another area of large opportunity, depending on the size of the building. So we can swap out a standard balcony railing with a BIPV balcony railing. And you can have either an opaque design so that nobody has a clue that there's a solar cell in it, or you can have a semi-transparent design so everybody and their mother will know that there is solar cell technology on that balcony railing. Choice is yours. There's a lot of things that we can do with cell alignment and placement. We can get really funky, or we can keep it conservative, whatever it is that, the design has in mind. So the benefits of BIPV are pretty clear, right? So you generate electricity. The technology is seamlessly and invisibly integrated into the building. So at no point anywhere on the building will you see a wire or an MC4 connector or anything, right? The aesthetic appeal is there, certainly, because we can make a solar panel look like a replica of brick, or a black metal panel, or a purple metal panel, or whatever it is that you like. So the aesthetics is there. Reducing the energy costs of a building is your client's biggest appeal. If they can reduce their operating expenses over the course of the next 25, 30, 50 years, of course, that's very appealing. Being sustainable, yes, being sustainable is important. However, if being sustainable is not affordable, that might be a challenge for your client. So we have developed a technology that addresses all of those needs, including affordability. So as I mentioned, the applications are many. Cladding is the largest area of opportunity, but there's also spandrel panels. There's integration into curtain wall or window wall. There are, acoustic sound barrier walls. There are, again, any surface that's touched by the sun could generate electricity. So it doesn't matter what the application is. There's a lot of ways that we can address the building envelope, some very standard ways and some very creative ways. So to give you an idea of the type of glass and solar rail projects, you can see in the photos there are a lot of different designs and a lot of different ways to apply them. The retrofit market is a huge opportunity. Our statistics are indicating that the retrofit market is growing by leaps and bounds every year because the amount of aging buildings in North America is huge. They're approaching 40, 50, 60 years. Facades are falling apart. In a lot of situations, the old buildings are not meant to have a heavy material coming in on top of it after the fact. So as a retrofit solution, this is something that is very easy to apply. So what better way to give a building a facelift than to wrap it up in a super lightweight blanket that looks fantastic and is generating electricity. So there are a lot of things to consider when we're looking at BIPV. As I said, we can make the facing look like anything. So it could be a solid monochromatic color, or we can make it look like brick or wood or stone, or you can take a photo of Vincent van Gogh's Starry Night. We can replicate that on the entire building or west elevation, whatever you like. I don't expect anybody to remember what color generates how much power. Unless you have some, I don't know what that condition is where you remember everything that you see. It's impossible. But there's two rules. If you can remember this, it'll make sense on how BIPV performs. Rule number one, the worst color is white or light yellow or pale green. Those are the worst colors you can put. But even those colors will generate 5 watts of power per square foot at minimum. Rule number two, the darker the surface facing color or pattern, the more power it will produce. So at minimum, you have 5. On the high end, you have 18. And then you have a world of possibilities in between. If you have a particular RAL color or a Pantone color that you have in mind for a project, we can test it to see how much power that will produce. So those are the two simple rules to remember. At minimum 5, and on the high end 18, and a million of opportunities in between. We can also apply different shapes and curved modules. We can play around with cell layouts. So there's a lot of different design elements that can come into play with a particular project. So it's not just straight flat panels. There are a lot of other opportunities. And then as far as assembly shapes and projections and recesses, there's a lot of things we can do, fins and canopies and, lots of different areas that you can apply photovoltaic panels to. How we deal with those details in returns. How do we deal with panel returns? How do we deal with termination against another building material? Those are all details that we will figure out once we look at a project. But the fact is, we can deal with just about any situation, and we have in the past. As far as the glass goes, we start off with 3 types of standard glass: satin, matte, and clear. Those 3 will pretty well give you the sort of matte finish that you're looking for, a glossy finish if you're trying to replicate like a shiny metal or something like that. But we can also do textured glass. So whether it's wood or fine or stone, you can get the color and the pattern, plus you can add a layer of texture to it. And it does not affect performance in a large capacity. So you can easily add textured glass and still get some very good performance. Collaborating with our architects is super important, especially in the early stages, because we have different installation methods, and you may not be aware of it, that can, ease the installation process for the project. And we also have, some very simple rules that apply to color selection. So if your client comes to you and says, I want a white building, and then they realize that BIPV is a possibility, and then they say to you, I want the best performance possible, as much power as I can generate, but they have a white facade. So it's a good thing that we come in early so that you can go back to your client and say, well, if you want more performance, you might want to think of a darker color on the facing. So whether it's a darker beige or maybe even a light brown or, whatever. It's important that we get in early so that we can help your client find that sweet spot between aesthetics and performance. Super important, right? System orientation. This is really important because the common misconception out there is that it's only the south side that generates electricity. I can tell you that is not the case. The south side is by far the best performer, no doubt, but east and west are super strong, and north, believe it or not, works on reflected light, non-direct light. So the north will generate roughly 30% of what the south side is doing. So when we look at a project, we need to understand, first of all, building location, because I can airlift this building located in Toronto and drop it in Arizona, and you're going to double the power. So geographic location is super important. Understanding if it's true north orientation or northwest or northeast, and then figuring out, what color are you looking at? And then we can take all of these different elements and figure out how much power is that building going to generate. And we look at all 4 elevations to give you the full potential. In the end, if you want to remove the north or just stick with the south or whatever, that's fine. But you certainly will have a full appreciation of what the power potential is when we look at all 4 elevations. If you're curious, you can get on our website and go to the project simulator and type in whether it's a balcony railing application or cladding application or spandrel panels. You can put in the square footage amount on each elevation, and you will get a report, from the drop-down menu, pick a city, a few other questions to answer, and it will give you a very accurate estimation on what the power potential is for that building. This is super important to understand because testing is, so there are 3 reasons why Mitrex is the largest and we believe the best in the world. Testing is one of them. Size of the company and the ability to manufacture 25,000 square feet a day is another one. And our ability to customize the surface facing. Those are the 3 reasons, but testing is super important to understand because we have done every test that you can imagine. We have done fire. We have done windstorm. We have done missile impact. We have done accelerated freeze thaw. We've done accelerated aging. We've done compression, tension, shear, buckling, torsion. You name it, we've done it. Every strength test, every impact test, every fire test, we've done it. I have 30 pages of testing information. If you want the details, you can either get it off our website or you can reach out to me. But it is super important to understand that every other organization in there does not have their fire testing, which means they cannot go above the 6th story. If that's the case and you're working on high rise, what's the point, right? So we have done all of the testing, both for building code compliance as a building material and photovoltaic module performance and safety. We've done it all. So S134, NFPA 285, E1886. This is my favorite, minus Miley Cyrus, of course. So we've done it all. And we're certified in Miami-Dade, listed on the California Energy Commission. So we've passed, and all that testing, has created a very superior project. Of course, if LEED certification is important to you, whether you're looking for, silver, gold, platinum, you've got a potential 40 points that this technology can provide. Companies and governments are responding. There are a lot of incentives and there are a lot of things that companies are doing to move in the direction of sustainability, super important. But one of the biggest things is the financial incentives available to your clients. In the US, the investment tax credit is 30%. That is a lot of money. So if your clients are serious about integrating a BIPV technology into their project, that's 30% the government will write them a check for if they're going to do that. So embodied carbon is something we get asked about all the time. Fact is, solar facade panels generate enough green energy to offset the carbon needed to produce them, unlike traditional materials. Okay, so 5 years or less. And that issue is taken off the table. The environmental impact is pretty clear. You can take 100,000 square feet and apply BIPV and have almost 100 or almost a megawatt of power, or get a lot of shovels, and I hope you have a lot of time because we got a plan, you know, to replace a lot of trees, right? So as far as why BIPV, it depends on the perch. It depends on your perspective. For today, we're looking at the architect's perspective. It's clear. You have thousands of colors and textures available to you. The aesthetics is there. At no point have I ever heard an architect say, yes, I would love to get that hideous rooftop panel on the side of my building all the way to the 30th story. Wouldn't that look great? No, which is why rooftop panels have been relegated to rooftop where nobody can see them because they're ugly. But now you can put that technology on the side of a building and nobody would have a clue. So the biggest challenge has been aesthetics. That's been taken care of. Different installation methods. Of course, if you can't install it easily, what's the point? We've taken care of that. You've got a high performance building envelope. You've got something that could provide lead points. You've got building code compliance and all the testing certification that you could ever ask for. ESG and EPD reports can be supplied. So that's from your perspective for today. GCs love to work with us because we're easy to work with, because our installation methods have been simplified. There's low scrap volume. The warranty is there. All of the testing is there as well. It's single trade on site. We're reducing the amount of trades on site, which makes the overall, ease of installation. Building owners love us. Bottom line is, at the end of a presentation, and I have done, I think, close to thousands at this point, a developer gets very excited at the technology. But a month later, they're going to forget who I was. They're going to remember solar technology. They're going to be looking at an Excel sheet with a little tiny number that says it's going to cost this much. The reaction is either going to be, oh my God, what? Oh, heck no. Or, oh my God, what? We absolutely have to look into this. And I can tell you that that reaction is more common than no. If it wasn't, we'd be out of business. So that's what they love. They love the cost of it. They love the fact that it's guaranteed, 25 years on performance, a guarantee that at the 25-year mark, the client is still going to get 80% of the original performance target. These are all things that, ka-ching, ka-ching, this is all they think about. Fact is, bottom line, a client has to pay for a facade, whether they like it or not. They have to clad the building. You are giving them a choice. Pay for a facade that looks great, costs them $5 million, looks fantastic but gives them nothing, or for $5.3 million, they get a facade that looks great and generates electricity for the next 30 years. That's what's important to the client. It always comes down to the cost. No matter how much the aesthetics and everything else is there, it's all about cost. So hopefully now you have a better understanding of what the basics of solar technology is, how it works. You understand how BIPV can be used in the cladding or railing portions of a building, whether it's a new construction or a retrofit. You understand how these systems integrate into the construction process, and you certainly have a better understanding, I hope anyway, of the potential electricity costs, reducing operating expenses for your clients. So that's it for the formal AIA presentation. I want to roll this so that you get an idea of projects that we have completed. This is a combination of projects that used our non-solar technology and projects that use our current solar technology. So it's a good mix of both. You can see that they're large-scale projects. They're all high-rises and very large-scale institutions. And they have integrated our technology in various areas. In some cases, it's the cladding. In other cases, it's the railing. In other cases, it's the, this is a retrofit. So one elevation, an existing 70-year-old building. These are balcony railing. So a lot of different types of projects have utilized this technology over the last little bit. And even though we only technically launched our technology 4 years ago, we've got about 10 projects completed. We've got about 30 in the pipeline that are under construction over the next 2 years. A ton of other projects over the next 2 to 5 years. All right, I'm going to stop sharing this. This video is on our website if you want to see it complete. I just don't want to take up any more time because I know that there are questions and I want to get to it.
There certainly are. All right, so we're just going to start at the top here, work our way through. If you have not submitted a question yet and you've got one, feel free to do so now, and we should have some time to get to them live.
Excellent.
All right, let's start off with Do you also integrate battery storage as part of the system design? And if yes, could you provide information on building area requirements for battery storage?
So that's a great question. And battery storage is not part of our turnkey solution. And I'll tell you why, because I would say probably 98% of the projects that we have done and are going to do not ask for battery storage because the building facade generates electricity on a daily basis. And in most cases, what the building generates on a daily basis, the building will consume on a daily basis. We have maybe one or two projects where the client has said, okay, but I want to save it for when I want to use it. Fantastic. If you want a battery solution, we will absolutely look at that as part of our solution offering and include that.
All right. What is the PV life replacement cycle?
So PV cells, there are solar installations that are currently almost 70 years old. That
Mm.
means that a solar cell that was manufactured 70 years ago is still producing electricity. So you can imagine the quality of the solar cells that are being manufactured today are going to have at minimum what that 70-year-old cell is doing and then some. So the performance is many, many, many years. Definitely going to outlive me.
Awesome. All right. Are the panels available in Miami-Dade hurricane capable units?
They certainly are. We are certified in Miami-Dade. One of the only companies, if not the only company, who has that certification for hurricane force winds and other, challenging uh, um, climate issues.
Awesome. All right. Next up, does the opacity on the solar railing impact the amount of power generated? And if so, by how much?
For sure. As I said, on an opaque panel, the lighter the color, the less power output you get, but you
Hmm.
still get 5 watts of power per square foot. If you
Hmm.
go with the dark panel, like we recently did a 17-story balcony retrofit, in that
Hmm.
particular case, they're getting 15 watts of power per square foot because they went with a very dark navy, almost black panel. So that got a lot more. If you're going for semi-transparent, where it's glass, where you can still see through the glass, but you can see the individual solar cells, we can get probably between 12 and 15 watts per square foot, especially if we put the cells closer together, because we can space them an inch apart, 2 inches apart. So the closer we space them together, the more power we get.
Hmm. All right, great. Is there a threshold of building size, facade square footage, budget, et cetera, that would make this product a positive recommendation for a client? Or is there a size where it doesn't matter?
Um, this is where I say, why? What's your why? Why do you want to integrate, or why does your client want to integrate BIPV into a project? If all they're looking for is to say, look, I put some BIPV on my project, but there's only 200 square feet, that's useless. 200 square feet will power your cell phone, right? If you've got a project that has a lot of cladding space and your client is looking to get the most, then there is definitely good reason to integrate. I would say that less than 10,000 square feet is not going to, it'll get you some, but
Right.
really it comes down to why. Why do you want to do it?
Hmm.
And that will determine whether it makes sense or not. If you are absolutely adamant that, it's only 1,000 square feet, but we want to get it on there, you're going to
Hmm.
pay a premium for that, obviously, because it's a small amount. We've got a fabrication facility that, manufactures 25,000 square feet a day. If we got to retool the entire plant for 1,000 square feet, you're going to pay the premium for that custom, right?
Yeah. All right. Let's see. Your website shows a gallery of projects in Canada. Is there a premium for projects in the States?
No, no, not at all.
All right. What happens after 30 years when the PV system stops producing electricity?
The facade falls off. I'm kidding. After 30 years, the building will continue to perform probably for another 70 years. You're
Hmm.
talking about a combination of tempered laminated glass, aluminum honeycomb together,
Hmm.
aviation grade epoxy. You've got a panel, as you saw in the testing video, that we're driving over,
Hmm.
taking a wrecking ball
Hmm.
to it, and nothing's happening. So as a building material, it's going to last a very, very long time. The performance will last at the 25-year mark. You're still going to get 80% of the original performance target. So do
Good.
you need to replace it after 30 years? Hell no. This thing could last 70 years. Yeah.
Awesome. All right. How does wiring work from panel to panel?
It is a very simple male-female connection. And the panels are in series, one connect to the other, connect to the other, connect, and the hip bones connect, you know that song. Anyway, they all connect to each other. But each row at every level will connect to the home run cable. And the home run cable connects to the inverter. That's simply put. Where those conduits will go, will they run along the edge of the slab? Will they go on the inside? Will we find some other way to lay it out? I don't know. Every project is very different and requires a different way of analyzing. It all depends on, is it a simple, flat building, or are we looking at some interesting cantilever designs or projected balconies or whatever? Every project is different. So we'll figure out what that wiring looks like on a project by project basis.
Awesome. Are there any applications for smaller scale residential projects?
Yes, actually, we have a product called eFacade Lite that was recently launched. It is a simpler version of our Pro Series. It is a pre-assembled, pre-engineered package of 150 square feet at a time. Think of IKEA in a box. Well, maybe not IKEA in a box, because I've ordered from IKEA and sometimes pieces are missing and it can be a bit. Anyway, think of a super IKEA in a box without any challenges. You have a handful of colors to select from. You have a handful of layout options. And it's 150 square feet at a time. So if you have a very small project and 150 square feet is all you need, then you could buy one of these prepackaged solutions, and that would make sense for a smaller project.
All right, awesome. Well, it looks like we might be nearing the end of our questions. This is just a comment that I'll share because it's very sweet. But someone wrote in and said they just want to compliment your presentation, naming and identifying the architects of the projects that you use. No one else does that. So I think that's, yeah, a great point.
Oh, thank you. You're welcome.
All right, and we've got one more that just came in. If the product goes onto an existing building, how thick does this, or how much thickness does this add to the overall building? How does this mount to anchors or onto an existing facade, and how would it marry to the windows?
Yeah. So the average size panel is roughly 1.25 inches. That's an average size panel. If we need to make it thicker for whatever reason, we can do that. We can make the honeycomb thicker. But on average, 1.25 inches is what you're looking at. Unless, and it's not the panel that's thicker, it's in a retrofit situation, especially, it's a rain screen application, right? So we can adjust the frame so that it's comes out more, or maybe not as much. So that's adjustable. And then the insulation can go behind. How we attach to the building depends on the existing structure. So we have to do what we call a remediation analysis. For example, the balcony retrofit that we did, the architect, or not the architect, the building owner said, yeah, oh, no, it's great. We can, and we thought, okay, but your slab edges are 50 years old. We have to drill on top of the slab edge. I don't know that old slab edges can receive that kind of penetration. They
Yeah.
didn't think about that until we put it up. And then we did the analysis, and it's like, no, man, your slab edges are falling apart. You got to repair that before we can come in. So in a retrofit situation, we have to do a site visit, and we have to figure out, can we drill right through and attach to the backup wall? Or, there may be another way of doing it. But typically what we do is drill right through to the substructure and attach that way.
Okay, awesome. All right, and next step, what is the cost difference roughly between a BIPV panel and a non-PV panel of the same material? And do you have resources we could share with the client?
Yes, I was waiting for that. I was hoping nobody would ask that. No, I'm kidding. So here's the thing. As I said earlier, your clients have to pay for a facade. What you're doing is giving them the choice. Spend 5 million on something that looks great, but gives them this, or spend 5.3 million on something that looks great and gives them power for the next 30 years. What you're doing is swapping out one material for the other. The cost of BIPV is very, very much in line and very competitive with metal panel pricing, ACM pricing. Okay? So the delta between what you have to pay or what your client has to pay for and what they could pay for is that, $300,000. And then the investment tax credit gets applied to that. Now you're looking at reducing that delta even more. So in
Yeah.
some cases, the cost of replacing your standard cladding material with BIPV is very little difference. Yeah. Now,
Awesome.
if your budget is stucco, probably not.
Probably
If your budget is metal panels or, some other higher mid-range material, we are very competitive.
not. All right, awesome. It looks like that might actually be our last one, which, yeah, I was waiting for that pricing question to come into. I feel like we always get that as well.
Okay.
All right, yeah, looks like just some comments, great presentation. So just want to remind folks, there's going to be a quick post-event survey. If you've got some questions that start to come up, like as you're leaving the event, feel free to leave them there, as well as any feedback about how the presentation was for you. We would love to hear. Feel free to grab any of the links from the chat before you head out for today. We've got a free demo link, as well as a link to the Mitrex page on Acelab. You can go explore some more about their projects. And yeah, that should be it. All right, I'm not seeing any more questions come in. So thank you so much for everyone who joined today for asking such great questions. We always see a ton of really awesome questions during this presentation. And Terri, you're an amazing presenter. Thank you so much for sharing all your information. We
My
appreciate it.
pleasure. My pleasure. Goodbye.
Have a good one, everyone.